Hello and welcome to this new video, and in this video we are going to start a new topic, probability. It's a very simple topic. It's a very interesting topic, and I'm very much sure and confident enough that you enjoy this topic, all the sessions we'll have under probability. I think the only thing I would suggest is that as we go through these sessions, you don't just rely on the information. Do some research. Try to go through a lot of questions, and that is the way to go. It will always help. Okay, we have all heard statements like, "There's little chance that it will rain this afternoon," or maybe let's say, "Our national soccer team has a good chance or stands a good chance of beating the Malawi national team." So when you look at the statements I've given, there is a chance that the national team, the Zambia national team, will win, or the Malawi team will win, or it's draw. Or the first statement when I said there is little chance that it will rain this afternoon. It could rain or it could not. So all these statements are examples of what probability is. So meaning that probability is the likelihood of an event taking place. The likelihood of an event taking place is known as probability. Now, probability is expressed in a ratio form. A ratio form that is probability is equal to the number of favorable outcomes over the number of all possible outcomes, where the A is the event, okay, is the event occurring, and we can see number of favorable outcomes over number of all possible outcomes. In a bit, this statement or this ratio is going to make sense. First of all, we need to understand that basically there are just two types of probabilities, and these include experimental probability and theoretical probability. And so we'll start with experimental probability. So, from the word experiment, meaning that these such of probabilities happened or occur as an experiment is taking place. You are trying to experiment, something. Okay? You're trying to experiment something. For example, let's try to experiment this certain concept by tossing a 1/4 cone 10 times. What are we trying to observe? Let us try to experiment and see how many times will the bird land facing up, and how many times will the coat of arm land face up. So the experiment says toss 1/4 cone 10 times and record the number of times the Zambia coat of arm will land face up and the number of times the bird will land face up. So for me, with my experiment, after tossing a cone, I came to observe or note that the bird landed face up 6 times and coat of arm landed face up 4 times. This simply means that I can express this in probability form using the formula on how to express probability, which we have just looked on. That probability of the event happening is equal to favorable outcome over all possible outcome. Or you can say total outcome. Or you can say total outcome. The P, remember, is probability. The A in bracket is the event happening. Is equal to favorable outcome over total outcome or possible outcomes. How can we express now these? After carrying out this experiment, by tossing a one-quarter cone 10 times, we have observed that the bird has landed face up 6 times and the coat of arm landed face up 4 times. So how do we show the probability? We can express this in probability form by saying that the probability, okay, that the event that will occur, which is bird, okay, facing up, will be equal to how many times did the bird land face up. So the bird landed face up 6 times. That is the favorable outcome for the bird. So meaning we are simply going to say 6 over what is the favorable outcome? How many times did we toss the coin? 10 times, because the experiment requested that we toss a coin, a one-quarter coin to be specific, 10 times. That is the total outcome, or the number of all possible outcomes, which is 10. Therefore, we are going to say over 10. The probability of a bird landing face up, if we toss a coin 10 times, is expressed as 6 over 10. And that is our probability. So meaning that this can be simplified by saying to its simplest term. We can simplify this to its simplest term. So we look for a number that can go into 6 and 10 without leaving any remainder and expressing this fraction to its simplest possible outcome. So let's look at a number. Let's say 2. 2 into 3, 2 into 6, sorry, I'm thinking ahead, is 3. Over 2 into 10 is 5. So the probability is 3 over 5. Let's look at how we can show the probability of coat of arm. Coat, I'll write an abbreviation, coat of arm is equal to the favorable outcome. How many times did the coat of arm land face up? 4 times. So the favorable outcome is 4 over what is the total outcome? Total outcome is still 10. So the probability is 4 over 10. This probability is representing the likelihood of the coat of arm to land facing up as we toss our coin 10 times. Therefore, if our fraction seems to be possible for simplification, then we can simplify. 2 into 4 is 2 over 5. That is how we can express the probability of a bird facing up or coat of arm landing face up as we experiment by tossing a 1/4 coin 10 times. Let's try to forge ahead and see if we can try and understand the concept using another example. This example says, in a certain secondary school, 100 pupils were asked whether they ate pork. 25 said they never ate pork. If a pupil is chosen at random from the 100, what is the probability that the pupil never eats pork? So first thing we have to understand is that probability is the event happening is equal to favorable outcome over total outcome. So meaning that we are simply going to say the probability of us picking a pupil who never eat pork is equal to what is the favorable outcome? Let's go back to the question and look at it. So the favorable outcome here, we're going to find it. In a certain secondary school, 100 pupils were asked whether they ate pork. So 100 is my total number or total outcome. Then 25 out of the 100 replied by saying we never ate pork. Meaning the 25 is the favorable outcome of us picking at a random someone or a pupil who never eats pork. So meaning we're going to say that the favorable outcome is 25 over the total outcome is 100. Therefore, this, let me just write here, never is equal to 25 over 100. This can be simplified to 1 over 4. So the probability of us picking at a random a pupil who never eats pork is 1 over 4. That is the probability. Okay, let's look at expected frequency. What is expected frequency? Let's assume that I know the total number let's say I know the total outcome and the probability has been given. How can I easily get to understand my expected number of picking? Let me try to use this same example here about expected frequency. So, you can say that I have been given to say 25 over 100 is the probability of me to pick at a random, to pick a pupil who never eats pork. So how do I get my expected outcome? I will multiply that with the total number of pupils. Therefore, this is over 1. That and that will give us 1. And 1 times 25 is 25. 25 divided by 1 is 25. So that is how I'll get the expected. So I know that my expectation of picking someone who never eats pork is 25. Now let's look at this. When the probability of an event occurring has been found using a small sample of a large group, that probability can then be used to predict the number of times the event will occur in the whole group. For example, in the previous example we've just looked at, let's say the school had 700 pupils. We would predict the number of pupils in the large school who do not eat pork. This prediction is what is known as the expected frequency. The expected frequency can be denoted sometimes in abbreviation EF. So how do we get the expected frequency? Let's look at it. We're going to use the 700. 700 pupils. Now let's look at this. We have been given total number of pupils as 700. Now, since we are relating this to the previous example, the probability of us picking a pupil who never eats pork is 1/4. Meaning that we will say 1/4 times 700. That means over 1. So 1 times 700 is 700. Over 1 times 4 times 1 is 4. Therefore, how many times can 4 go into 700? That is 175. So meaning that if we had a number of pupils summing up to a total of 700 pupils in the school, for me to be able to understand that out of the 700, my expected frequency or the expected number of me to select or pick a pupil who never eats pork is actually 175. That is how we can calculate expected frequency. Let's look at, in general, what is happening. What is basically happening is simple. We are saying that if the probability is A over B, okay, of an event, then the expected frequency is to be found by multiplying by n. So, the expected frequency is denoted by the formula expected frequency, open bracket, the event occurring is equal to A over B, which is the probability times n, where n is the population of or the size of the given measure, and A over B is simply the probability of what you've been asked to find. And that is basically how we can calculate the expected frequency. And that's why when you look at this, we said the probability is 1/4 times 700. So this probability is the A over B times 700, which is the total number of the pupils, which is n. Which is what? Which is n. That is how we can basically calculate the expected frequency. But let me try another example and see if you can clearly understand or get the concept. If a raffle where 500 tickets were sold, the probability of Mr. Kacheva winning is 1/50. How many tickets did he buy? So we want to understand the expected frequency. Okay? The expected frequency. For us to know that the probability of winning, we know, is equal to 1/50. Then, if this is the probability of Mr. Kacheva to win, out of the 500 tickets, what is the expected frequency for him to have this probability? Meaning we want to understand how many tickets he had to buy for him to stand a chance of 1/50. So we are going to say the expected frequency, event happening, which is win, is equal to 1/50 times the total number, which is 500. So what are we going to do? We are going to say 1/50 times the 500 over 1. 1 times 500 is 500. 50 times 1 is 50. So that and that will go. We'll have 50/5. So probably that is going to be 10. So meaning that the probability of Mr. Kacheva to stand a chance of winning with a probability of 1/50, he had to buy 10 tickets. He had to buy what? 10 tickets. He had to buy 10 tickets. I hope you have basically understood about probability and the first type of probability, experimental probability, and the expected frequency. Thank you for watching and have a blessed day.